Hi everyone, this is Dr. GVR Seshagiri, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. In previous session, we have learned about rope drives. So generally, rope drives are classified into two types. One is fiber ropes and wire ropes. So in previous module, we have discussed about fiber ropes. Now in this module, I want to discuss about wire ropes. In this module, the topics will be covered. So like this, the construction details of wire rope drives and design calculations of wire rope drives. The wire rope drive is widely used where a large amount of power is to be transmitted from one pulley to another pulley over a long distances. It means we can use the wire ropes up to 150 meters apart. But in the case of rope drives, fiber ropes, we can use only up to 60 meters apart. So that's why the wire ropes are widely used in elevators, main hoists, and cranes, conveyors, hauling machines, and suspension bridges. The wire ropes are lighter in weight, and these gives very noiseless operation, and also withstand shock loads, and more reliable. And these wire ropes do not give sudden failures, and also more reliable. The efficiency of the rope drive is very high and very less expensive and low cost. The construction details of wire rope is as shown in figure. In this figure, shown the construction of a wire rope. It consists of mainly three parts. One is core and wire and strand. This is the wire rope. Total entire is known as wire rope. The center wire. The core is the center part of the wire rope. The strand is the multiple of it having the multiple of wire ropes. This is a single wire. This wire or number of wires are twisted into in the form of strand. It may be 7 or 19 or 37. The multiple wires twisted in the form of strand. And again, the strand. The number of strands are twisted around a core to form a wire rope. So this is the major construction of wire rope. So we'll see how to designate the wire ropes. So generally the designation of wire ropes are like this: 6x7 wire rope and 6x19. The center one is core. And in this one is a strand, and this one is the small one is a wire. So here see 1, 2, 3, 4, 5, 6, 7. 7 wires are there, and 1, 2, 3, 4, 5, 6 strands are there. So it means 6x7. So the designation of wire rope, the 6 is indicates number of strands, and 7 is indicates number of wires. So the strand, the wire rope having 6 strands, and the strand having the wires is 7. So similarly the 6x19 also same, the 19 wires, and 6x37. So like this we will give the designation of wire rope. So on the detailed diagram shown in this slide. So in this is the total assembly of rope, and in this color indicates wire and strand and core. So what is the designation of this wire rope? How many strands are here? 1, 2, 3, 4, 5, 6. 6 divided by how many wires are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 6, 9, 12. Total 12 wires are there. So total 6 by 12. So like this you will give the designation. So this is the wire rope diagram. So next the classification of wire ropes. So according to their the direction of twisting. The first one is cross or regular lay rope. In regular lay rope, again classified into right hand and left hand. So in this, the wire ropes are twisted in one direction. So that is right hand direction, and the strand is twisted opposite to this direction. So the wire direction, the twisting direction, and the strand direction, twisting directions are not in same direction, opposite direction. So it may be right hand or left hand. So that's why they classified into right hand and left-handed lay ropes. These type of ropes are called as a regular lay rope. And in the case of parallel or Langley, so in this, the wire rope for twisting direction and strand twisting direction are in same direction. So it may be right-handed or left-handed. So that's why these type of ropes are called as Langley ropes. And the composite or reverse slide ropes. The composite or reverse slide means the combination of these two. So it may be Langley and regular ropes. So clearly given in this slide, the diagram, the regular lay or cross lay, here see the directions, the red arrow indicates wires and the blue is strands. See the regular lay, the direction is like this, and the y direction is like this, and the strand is opposite direction, right way, and alternate reverse the composite rope, and in this see the Langley or parallel lay in the same direction. So the strand twisting direction and y twisting direction also same. So left lay, the direction also the is left hand side. So this is right hand side. Some design calculations. So I will tell here. So the many stresses are acting on wire ropes. So that is one is direct stress and bending stress, and impact load also will act on wire ropes. We will see one by one. The first one is direct stress due to the axial load, and this is the direct load stress formula, that is capital W plus small w upon by A. So already W is load lifted, and small w is the weight of the rope, and the net cross sectional area of the rope. And the second one is bending stress. When the rope wound around the sheave or drum, the bending stress will calculate by using this formula. Here E, capital E is the Young's modulus of rope material, and wide diameter, and fully diameter is D. So equivalent bending load on the rope we will calculate by using this formula. Next one is stresses during starting and stopping. So during starting and stopping, the rope and the supported loads are to be accelerated. So that's why first we will calculate some induced load. So initially how much load induced? So that is WA is equal to capital W plus small w upon G multiplied with acceleration. The corresponding stress is load per area. Next, impact stress. So impact stress will calculate by using this formula, and also all abbreviations shown in here. So A is area, cross sectional area, and E Young's modulus, and L length of the bar, delta L deformation of the bar. P already know that force, how much force will act on this rope drive, and the delta L is deflection, how much deformed under this load. The sigma is stress induced in the bar, and h is height through which the load falls. Clearly shown in this diagram. The impact load on starting may be obtained by the impact equation. So the impact load equation is you can take this equation and calculate the stress. And the velocity of the rope you can calculate by using this relation, square root of 2a into h. And in no slackness in the rope, their h is equal to 0 and velocity also 0. So take these two values 0 and substitute in the previous equation, we will get that impact load during starting, and the corresponding stress also we will calculate. Next we will see design procedure. The first one is identify the suitable type of rope, wire rope from a table. So you have to take the table from a design data book, handbook for a particular application. And second one is find the design load. So by assuming factor of safety 2 to 2.5 times the factor of safety given in the table. First we assume, suppose in the design data book the table, the factor of safety is 7 for particular application. In this problem solving, so multiply with 2 or 2 to 2.5, 2 to 2.5. So suppose multiply the maximum value 2.5 multiply with 7, you will get 15. Take this factor of safety value for all remaining calculations. So next, third one is find the diameter of the wire rope, that is small d. And fourth one is diameter of wire and area of rope from table. Find the various stresses or loads acting on the rope. And the next step is find the effective stresses during normal working and during starting and acceleration. So as we discussed in a previous slide. So finally find the actual factor of safety. So this factor of safety value compare with the given tabular form in given table value, the factor of safety. So if the actual factor of safety is within the permissible limits, then only your design is safe. So that means your calculated the actual factor of safety should be less than the design data book table value. Then only your design is safe. So like this, how to solve the wire rope design problem. So we will see here in the one problem. So take this problem. Select a wire rope for a vertical main hoist machine to lift a load of 55 kilonewtons. So your total load is 55 kilonewtons. For a depth is 300 meters. The row speed is 500 meters per minute. So the time is 10 seconds. So how to solve this problem? So according to our given procedure. So as we discussed in a previous slide, design procedure apply that design procedure for this problem. We will get so all values and finally fix select a wide rope for a main hoist machine. So for this I have taken the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.